Okay, to start with factorizing, you're going to need to know how to do factorization because it will help resolve a lot of issues, especially when it comes to algebraic fraction questions. As you saw earlier, we're going to have to do some factorization for cancellation. So I want to just go over factorization very quickly before we start matrices. Factorization, let's take this example over here. We have 2z squared plus 3z minus 9. So the first thing is you're going to determine your a, b, and c values. So a is equal to 2, b is equal to 3, and c is equal to minus 9. You are going to multiply your a with your c. Okay, this is the first step. A times c. A times c meaning it's going to be 2 times minus 9, which is equal to minus 18. That's the first thing. The second thing is you're going to take your b value by itself and you're going to look at it, which is equal to 3. And then, so we have our minus 18 and we have our 3. So we need to look for values. When you multiply, you will get negative 18, and when you add, you get 3. With trial and error, you can check, and you're eventually going to see that the numbers 6 and minus 3, when you multiply them, you get minus 18, and when you do 6 minus 3, this is going to be equal to 3, which is what we are looking for. Okay? So in this case, when we have a not equal to 2, a not equal to 1, so a is not equal to 1, the next step will be step 3. I mean, this will be step 3 technically. All right, so step 4 would be to rewrite this equation. Okay, so step 4 would be rewrite equation as follows. So 2z squared will stay the same. And the plus 3z we will break down. So this we will break down into these two parts, which will add up, or in this case subtract, and will be equal to minus 3. So it's going to be plus 6z minus 3z minus 9 equals 0. We didn't change the equation at all because 6z minus 3z is equal to 3z. So we didn't change the equation at all. Okay. From here, we can start looking at each of these separately. So we're going to look at this part separately, and we're going to look at this part separately. Okay? And we're going to try to factor out anything we can. So in this case, we can take 2z as common. All right? So we'll take 2z as common. What will remain is z plus, out of the 6, we are taking a 2, so we're going to be left with 3. And the z we are taking out, so we will be left with z or z plus 3. All right? We will do the exact same thing for this right part as well. So we're going to take here, what can we take common? We can take negative 3 as common. So we'll take negative 3 as common. So if we take out negative 3, we'll be remaining with z. If we take out negative 3 from the minus 9, we will be remaining with plus, because negative and negative will become plus. And 9 divided by 3 is 3. Okay? And this will be obviously equal to 0. So now if you notice, we are left with another common here. This is z plus 3, and this is also z plus 3. And whatever is remaining outside, in this case, it's the minus 3, 2z minus 3, we are going to take that also as common on one side. So our final answer will look like this. 2z minus 3, okay, multiplied by z plus 3 is equal to 0. And this is how you would factorize for, this is the most complicated way, like most complicated question that might come for factorization. So if you know how to solve this, you'll be able to solve almost any factorizing question. All right. It does not matter, يعني, if you put 6 or minus 3 first. Is that what you're asking, Sayed? يعني, the minus 3 يكون أول أو 6 يكون بعده. It's going to be the same thing. And just to show you that, so if we have 2z squared, and you wanted to put the minus 3 first, okay? Minus 3z first. So let's do it this way. Minus 3z plus 6z, as long as this is correct when you subtract or add, all right? And it will give you 3. And when you're multiplying, it will give you the minus 18, which is a times c, all right? And then we have our minus 9. So if we do it this way as well, it's the same thing. So the first thing we can take common in the first part here, if we're looking again at just this part by itself, and then we're going to look at just this part by itself. What can we take common in the first one? We can only take the z common outside, and we'll be remaining with 2z minus 3. All right. And the second part is going, what can we take common? We can take plus 3, because 6 and this is 9 have 3 as the greatest common factor. فبيبقى لنا with 2z minus 3 again. So if you notice, we have the exact same factors that we are going to get, just the order is swapped, but it's the exact same answer. So we're going to get, if we just take the z plus 3 first, z plus 3 multiplied by 2z minus 3. So it's exactly the same answer you are going to get. It doesn't matter the order of which one is first. Just always take the first two together and then the last two together. وبعدين تحلون. All right? And this is how you'll factor out. Now, we are not done with the question. We need to find the solution, obviously. So now, step 5 is find the solution by equating each to 0. What do I mean by that? What do I mean by each? معناته هني we will take our 2z minus 3 and we're going to make it equal to 0, and we will solve, and we will take our z plus 3 and we will make it equal to 0 and we will solve. إنزين? So if we solve this, we're going to get 2z is equal to 3, and then z is equal to 3 over 2, and this is our first solution. Here, if we solve this, we just get z is equal to negative 3, and this is our second solution. It is a quadratic, so we have to have two z's as an answer. Very straightforward. It's very easy. The only thing maybe people might struggle with is knowing what to factorize out here, and this comes with practice. You just need to find the largest common factor. A note is always the first part, you're going to take z out as a factor, and then you're going to have to look at the constants around it, all right, the numbers around it, and see if you can find out any common factors. And then we're going to equate each to 0. Why are we doing this step? Like, why are we doing step 5? Because when we are multiplying by 0, that's when we get our solution. So just so you understand, if the blue part is 0, our solution will be correct. And if the orange part is 0, our solution will also be correct. Now we want this to be equal to 0, because 0 times anything is going to be 0. So that's why we equate each part to 0, so we can find the final solution. All right? So I just wanted to cover this factorization very quickly. Again, I will just do one quick recap. First thing you will do is find your ABCs and multiply A with C. You will get minus 18. Then you will look at your B value, which is 3. Then you're going to try to find what two factors when you multiply. So when you multiply, you will get 18. All right. When you multiply, you get 18. And when you add up, you're going to get 3 as an answer. So 6 plus minus 3 or 6 minus 3 is when you multiply them, you get 18. And when you add them up, you get 3. Then you're going to rewrite the equation using these two factors. All right. We multiply A and C because we don't have A equal to 1. This is the rule. When you don't have A is equal to 1, you have to multiply A and C. When A is equal to 1, you technically are multiplying, but when A is equal to 1, and 1 times anything is just C. This is why we're multiplying. And then once we have found our factors, we're going to rewrite the equation in the same way. So 2z squared and the minus 9 will not change. Just the plus 3z are going to be the same factors. So it's going to be 6z minus 3z, the same things that we found here, to be equal to 3, which is their b value. And then we're going to take the common factors out from the first two and the last two. We're going to have the same thing in the brackets or the parentheses. If it's not the same thing in two parentheses, know that you might have made a mistake somewhere. So double check your work, or your factorization is incorrect. And then whatever is remaining outside, you are going to take as a factor itself. So the 2z minus 3 is going to be the first factor. Z plus 3 is going to be our second factor, equal to 0. And then we're going to equate each part to 0, solve, and we will get our z1 and z2 values. All right. Let us get into matrices. So, all right, matrices. Matrices might be one of my favorite topics in all of mathematics because that's where linear algebra comes from. It is mostly used to solve very complicated linear equations. Remember, linear equations are equations where x is just has no power, so it's not x squared or x cubed. And matrices are a very strong way of solving that, and we will see that now. But the basics, what is a matrix? A matrix is usually a multiple rows and multiple column table, all right? It's like somewhat like an Excel table, which will have random values, or not necessarily random, but values that are assigned to it. And we are always going to look at the number of rows, which is here 1, 2. We have 2 rows. And let me just make this matrix a bit bigger, 7 and 2. And we're going to look at the number of columns. So this is column 1, column 2, column 3. All right. So this is how you look at a matrix always. Yani this is how you should memorize it. These are your rows and these are your columns. And then your rows and columns is how you will define a matrix, or also it is known as the order of the matrix. So in this case, we have 2 rows. So it's going to always be rows times columns. This is how you will always define any type of matrix you see. So it's going to be rows times columns. In this case, we have 2 rows times 3 columns. So we're going to call this a 2 by 3 matrix. This is how you will identify this matrix. So if they tell you what order is this matrix, it's a 2 by 3 matrix. This is how you write it, 2 times 3, but this is how you would say it. It's a 2 by 3 matrix, okay? So this just means this, all right? And this is the basics of what a matrix is. It's simply just like a table where you have, or an array, as most people will be defining it later on. You'll see this a lot if you're going into ICT, especially. In engineering, you're going to see math everywhere. That's normal. But in ICT, you're going to be dealing with matrices a lot, because in coding, you deal with arrays and matrices a lot. So you guys need to have a very good, strong fundamental concept of what matrices are and how they are used. So this is the basics of a matrix. You have rows and columns, and it looks like a table. All right. So if I want to call out any specific value in this matrix, so for example, I want to call out this location. I would say this is in row 1, column 2. Because if you notice, it is in row 1, okay, column 2. So you're always identifying the row first. Okay, this always comes first, and this always comes second. All right. Your rows always come first and your columns always come second. So first thing you'll do is row, the second thing you will do is column. This is, you need to get used to this all the time. So the number 4 is in row 1, column 2. Or sometimes they might write it as A1, 2. All right? So this is how they would represent it, yani, to tell you that this is the first row, second column. All right. This is just some extra information. I don't think this is what you guys have. What you guys need to do to know is how to add, subtract, multiply, and do all of that with matrices. Now, to do that, let's take some examples actually from the worksheet rather than make them up, and I'll explain as we use them. All right. So we have these multiple matrices given. So this is A, this is B, This is C, and this is D. I want you guys now to tell me what is the order of matrix A? So I'm going to make this a bit larger. Matrix A, matrix B, matrix C, and matrix D. I want you guys to tell me what is the order of matrix A. A is going to be a 3 by 3. So A is a 3 by 3 matrix. What about B? I want to know if you guys understand. What about B? B is a 1 by 3 matrix. Now let me explain why. So the first one should be very straightforward. You have 1, 2, 3. Today's الدرس مع اليوم بيكون all matrices. All right. So 1, 2, and 3. This is the number of rows. So this is the first part. Okay. Now, if I move this a bit to the side, so A is a 3 by 3. Now let's look at the columns. We have 1, 2, 3. So 1, 2, 3. This is the number of columns. This is how you will always define the order of a matrix. Same thing for B. B, how many rows we have? We have 1 row. 1 row. So this is just 1. All right. These are your columns. Here you have 1, 2, 3. So you have 3 columns. Same thing you will do for everything else. C is a 3 by 3 as well. And D is a 3 by 1 because you have 3 rows, 1, 2, 3 rows. Okay, so that's your 3. And you have only 1 column. Okay, this is how you would define each of these matrices. Now, for addition or subtraction, the rule is matrices have to be equal in size. For example, these two are both 3 by 3s, so you can add them. So this you can add, it is correct. Why? Because this is a 3 by 3 matrix, and this is a 3 by 3 matrix. So these two you can add without any issue. All right, because the size has to be exactly the same, the complete size. All right, both the number of rows and the number of columns have to be exactly equal. So if you have a 3 by 3, we have a 3 by 3. If we have, for example, another case where we have 1, 2 plus 3, 4. Okay, so this is the first matrix. It's a 2 by 1. The second one is a 2 by 1. Again, these are exactly the same size. These two are equal. So you can add these. It is correct. Now the question is, how are you going to add these? The way you will add it is, so these will be equal to, you're going to look at the first value and you are going to add it with, you're going to look at the first value and you're going to add it with the very first value here. And you're going to look at the second value and you're going to add it with the very second value here. And your solution should also be the same size matrix. So this has to be a 2 by 1, where the first solution is going to be here, and the second solution is going to be here. So 1 plus 3 up here. So this is going to be 1 plus 3, and this is going to be 2 plus 4. All right? This is how you would do it. So this is also going to be a 2 by 1. No, we cannot. If we do not have an exact, so the question is, what about if we have a 3 by 2 and a 2 by 3? The reason you cannot is because you're not having the exact number of rows. The rows have to be equal to the rows and the columns have to be equal to the columns. Yani, if you have this 1, 2, and this, and you want to add them 1, 2, you cannot. Or let's call this 3, 4. This is an incorrect operation. You cannot do this. Why? Because you have a 1 by 2 here, and you have a 2 by 1 here. So the rows and columns are not equal to each other. They have to be exactly equal. يعني each row, the number of rows is equal to the number of rows, and the number of columns are equal to the number of columns. So we cannot do this operation. All right? This is not possible. Okay? Now, عشان ما تلخبطون, it's not multiplication, just not possible. Now, simply, like I said earlier, when you are doing addition, you're going to just take the first term, add it to the first term, second term, add it to the second term, and this is going to be your matrix. Just the solution is also going to be the same exact size as your original matrices. فبيكون عندنا 4 and 6 as our final answer. And again, this is a 2 by 1 matrix. Okay, that's how you add. Very straightforward, very simple. So if we take A and C, just to have a better example, if we take these two and we're going to add them up, exactly the same idea. All right, these two are equal in size. They are 3 by 3, and this is a 3 by 3. So the rows are equal to each other. Yes, and the columns are equal to each other. So it's perfectly fine to add them. All right, so these two are equal, so we can add. Now, let's look at each value. So this is how you're going to add. You're going to add the 1 to the 0. You're going to add the 0 to the 6. You're going to add the 1 here to the minus 21. This is how you will add. And then you're going to add the 2 to the 2 over here. And then you're going to add the minus 4 to the 4. And then you're going to add the 3 to the minus 9. And then you're going to add the minus 6 to the 5. And then you're going to add the 1 to the minus 7. And then you're going to add the 1 to the 8. And your solution is also going to be a 3 by 3 matrix. All right? It has to be equal to the same size. All right? So you're going to do 1 plus 0 in the very first one. It's going to be 1 plus 0 over here. This is your first row. First row, first column. Second row, first row, second column is going to be 0 plus 6. 0 plus 6. This is just what we did from there. Then we're going to have minus 21. 1 minus 21. It's 1 plus minus 21, so it's 1 minus 21. You guys should already know that. بعدين عندنا 2 plus 2. So 2 plus 2. Then we're going to have 1 minus 4 plus 4. Minus 4 plus 4 in the middle part. This is how you would solve an addition for the matrix, all right? Then we're going to have 3 minus 9. So 3 plus minus 9. Then we're going to have minus 6 plus 5. Then we are going to have 1 and minus 7. 1 plus minus 7. And finally, we are going to have 8 plus 1. So this is how you are going to solve a matrix. This you're going to simplify each one. If we simplify it, the last answer, the final solution is going to be 1, 6. 1 minus 21 is 20, or negative 20. 4 minus 4 plus 4 is 0. 3 minus 9 is minus 6. Minus 6. Minus 6 plus 5 is minus 1. 1 plus minus 7, or 1 minus 7, is minus 6. 8 plus 1 is 9. Okay? This is what your final matrix will look like. Again, it's a 3 by 3, same solution as same size or order as the matrices you are adding. And the same case will go into subtraction as well. All right? Now, I'm gonna make my own small matrices now, so I don't have to take too long to write this all down, but I wanted to show you one example of how it will be for a large matrix. You're just gonna go in order, one by one. All right, when you go in order one by one, everything just will work out properly and you will not get confused. We're going to add each value to its corresponding value. Now, what about subtraction? Let's make a simpler matrix. So let's say we have 3. Let's make it a 2 by 2. All right. We have 3, 4, 1, 2 over here, minus, let's say we have -2, 5, 1, and -3. Okay. First thing we need to check is the size. This is a 2 by 2. This is a 2 by 2. All right. They are equal. We can move on. This is the first thing you do when you're adding and subtracting. There's 2 ways you can do this. All right. There's 2 ways you can do this. You can directly solve this, and then 2 times 2 and 2 by 2. So the answer is also going to be a 2 by 2. You can directly solve this by just looking at each one. So 3 and the -2, you're going to do 3 minus -2 because subtraction is in between. And you will do the same for each one. So 1 and 1, you're going to just do 1 minus 1. And then you have 4 and 5. You're going to do 4 minus 5. And you're going to have 2 over here, 2 and -3. So you can do 2 minus -3. You can do it directly this way. This is correct. There's nothing wrong with it. Or you can first multiply the minus into this and then add it. What do I mean by that? So if I just rewrite this again down here, what you can do is before we add all of these, all right? We had these to be 1 and 2. So you can distribute this minus into each one of these and turn it into a plus. If that makes your life a bit easier. عشان you have less minuses to deal with. And how would that look like? It will look like this. 3, 4, it's not a fraction. 3, 4, 1, 2. Minus, it will turn into plus. And the -2 will become +2. The 1 will become -1. The 5 will become -5. And the -3 will become +3. So what happens is all the signs will simply just flip. Okay? And you will change the minus into a plus. So if you notice this minus here changed into a plus over here. All right? And then you can solve it normally as you would solve a plus. You're going to do 3 plus 2, 1 plus -1, 4 plus -5, and 2 plus 3. The reason I'm explaining this concept is, in this case, okay, you can just directly do negative, and it's very easy if you just do minus this and minus that. However, in some cases, it's the minus is going to be by itself. What do I mean by that? يعني مثلا, I tell you the matrix A is equal to 1 and 2. All right, very simple. Or 1 and -2. I would say find minus A. All right. Now you know how to find minus A. All you're going to do is flip the signs of everything inside. Tamam? So this is the concept I was trying to also show. We also can do something else. So if this is A, we have 1 and -2. Let's say B is equal to 1 minus 3, 2, 1. Okay. If I say find 3B, what does this mean? This means you are going to multiply 3 by each and every value inside. This is what that means. 3 times -3 and 3 times 1. Okay, so 3b is simply going to be equal to 3, 6, 3 times -3 is -9, and 3 times 1 is 3. This is what they call constant multiplication. When you're multiplying with a constant like 3, you can just distribute the 3 into everything, right? So for example, they could give you a question like this. So this is C, -1, -2, 3, 2, okay? This is our B and this is our C, okay? I'm just gonna copy paste them again here. We're given these two matrices. They're both 2 by 2s, so we can do multiplication, addition and subtraction. These are 2 by 2s. So they are equal. We can proceed to add and subtract them. So that they might give you a question like, what is 2b minus 3c equal to? Okay. So in this case, what are you going to do? You're going to look at 2b by itself. All right. And you're going to look at minus 3c by itself. And you're going to find those answers first before you move on. So if we're looking at 2b is equal to, we know that b, this is our b, so we're just going to multiply everything by 2. So 2 times 1, 2 times minus 3, 2 times 2, and 2 times 1. Okay? This is our 2b. If we're looking at minus 3, minus 3c, I mean, so we're going to write here minus 3c is equal to, so we're going to multiply everything by negative 3. So minus 3 times minus 1, minus 3 times 3, minus 3 times minus 2, and minus 3 times 2. Okay? Now, the question was to find 2b minus 3c. Let's simplify these. So 2b is equal to 2 times 1 is 2, 2 times minus 3 is minus 6, 2 times 2 is 4, 2 times 1 is 2. Minus 3c is equal to minus 3 times minus 1 is positive 3. Minus 3 times 3 is minus 9. Minus 3 times minus 2 is positive 6. Minus 3 times 2, or negative 3 times 2 is negative 6. Okay? So this is what we found out to be our 2b and minus 3c. Now we can solve 2b minus 3c by just adding these two directly. All right? So again, let me lower this a little bit. We're going to just do 2b plus minus 3c, all right, is equal to, and we're going to find the answer. So we're just going to do this plus minus 3c, which is 3 minus 9, 6 minus 6. And this is going to be equal to, and we're going to add each component again with each other. So the 2 with the 3, the minus 6 with the minus 9, the 4 with the 6, and the 2 with the minus 6. And then you can figure it out. The final answer is going to also be a 2 by 2. I feel it's always going to be a 2 by 2. All right? Mish'al, it should be working. Yani, I can see you typing in chat. I don't know if you can see the stream though. Okay? Now, everyone else can see my stream, right? I'm not just explaining to myself, I'm assuming. I'm pretty sure someone would have told me if they cannot see my stream. Yeah, all right, just making sure. Nzin. Now, is this point clear? So here, what I did is I included the negative 3 in the multiplication. You could keep the minus outside and only do the 3c, and then the final matrix, you're just going to be doing minus. All right? You could do that. Yani here, and the reason I did plus is because I already took into consideration my negative 3 when multiplying to c. This is just the way I like to do things. All right? The way I like to do things. If it is more easier for you to comprehend and keep the minus outside and just multiply 3 into c and then just do minus over here, you can do that. I don't like solving matrices this way, and negatives eventually become too much and you make a mistake. All right? But this is the whole concept of addition, multiplication, and scalar multiplication as well. Yeah, so that's pretty much it. Anyone has any question about addition and multiplication, addition and subtraction before I go into the next concepts? I believe transpose and determinants. Is it clear? All right. Let's go to the transpose of a matrix. So we have something called a transpose. All right. What does the transpose stand for? Transpose, the way you would write it is, let's say we have a matrix A is equal to 1, 2, 3, 4, 5, 6. Okay, this is our matrix. Now let me see if you guys are still with me. What is the order of A? I need you guys to tell me what is the order of A. Then what is the order of A? This is a 3 by 2. The reason I'm asking this again is because now always the order is always going to be important to know. A 3 by 2. Excellent. You guys know what you're talking about. Perfect. فعندنا 3 columns, 3 rows, sorry, and 2 columns. All right. So we have 2 columns and we have 3 rows. Okay. Transposing means we are going to swap our rows and columns. This is what the transpose means. Transpose. We are going to swap our rows with columns. شو معناته؟ معناته you see the green 2 هني, this 1 and 2. These are going to be our new rows. And this 1, 2, 3, these are going to be our new columns. How will that look like? First of all, the proper way of writing it, the notation, is going to be a to the power of t. That's what transpose means. So when we swap this, our transpose is going to be now a 2 by 3. All right? So it's going to be a 2 by 3. Let me keep the color code so you guys don't get too confused. 2 by 3. So originally it was a 3 by 2. It became a 2 by 3. So now we're going to have 1, 2 over here. And we're going to have 1, 2, 3 over here. 2 by 3, right? This is a 2 by 3, a simple 2 by 3. Now we're going to write the 1 in order and the 2 in order from left to right. Again, just to make sure you are right, look at where 1, 1 is. And then 1, 1 is here. So we're going to write 1. Look at where 1, 2 is. 1, 2 is over here. So we're going to write 2. Whereas 1, 3, 1, 3 is over here. So we're going to write 3. And then we're going to write the next column the same way, 4, 5, 6. The reason I wrote them in order is intentional so that you guys can see in order how it will look like. This is what you call the transpose of a matrix. Very simple, very straightforward. All you have to do is if you do this method, you're never going to get confused. Write your number of columns and number of rows in order, and then 1, 2, 3, 1, 2. And then write them in order again when you're going to do the transpose. And then make sure that your number 1 is matching your number 1, your number 2 is matching your number 2, and that's it. Is this clear? Very easy, right? Let's do one more example and let's make it a 3 by 3. So let's say we have B is equal to 4 minus 3, 2, 6, 1, 0. We are not using 0 enough. 0. And we have minus 1, 10. I don't want to use double-digit numbers. 9 and 5. Okay. This is B. So B transpose, what is it going to be? Remember, yes, this is a 3 by 3. That is correct. All right. But keep in mind, when we transpose, we are still flipping these two 3s. These are the rows and columns. They're going to be swapped. So for the transpose, this is going to be 3 by 3. If you notice, the color has swapped. All right? The color is going to swap. So in this original matrix, these are your rows, 1, 2, 3, and these are your columns. Oh, I usually do it the opposite way. And then doesn't matter. And these are your columns. And then okay. Actually, just so that the whole document is consistent, let's just swap the colors. Don't get too confused. I'm just gonna fix it now. All right. So again, these are your rows and these are your columns. So you have 1, 2, 3, and we have 1, 2, 3, right? So we have 3 rows. Our first 3 is in blue, 3 rows. Second 3 is our 3 columns. B transpose means we are swapping our rows and columns. So our columns are now here, 1, 2, 3, and our rows are going to be at the bottom here, 1, 2, 3. This is what is happening. Another way you can look at this as well is, let's look at columns, for example, or let's look at just rows. So if you want to write it as rows, for example. So this row is going to be going in order over here. Then this row is going to be going in order over here. And then this row is going to be going in order over here. You can do the exact same thing with the columns instead. If you want to do the columns, it works the exact same way. So if you do it this way, you just now fill in the blanks. So we start with 4, then we go -3, then we go 2. Again, we start with 6, then we go 1, then we go 0. You just go in order, and then you go -1, 9, 5. And to double check, make sure that the location of each number is fitting. So 2 blue, 2 green. So 2, 2 is the same, 2, 2. All right. Let's look at 3, 1. 3 blue, 1 green. 3 blue, 1 green. It is -1. Okay, so it's fitting. Let's look at, I don't know, 1, 2. So 1 blue, 2 green. 1 blue, 2 green. It's -3. All right, this is also -3. Correct. This is how you will be doing the transpose all the time. ما أعرف شو قصدك بالعكس, but this is the way it is done. Like I just showed you, that's how you would solve it. That's how you would double check. This is the best way to double check. Always reference the column number and the column number and the row number. It has to still be matching. Yes, the column now is a row here, but it still has to be matching the same number. So you would go 2, for example, 3. 2 blue is now a column. It used to be a row, it's a column. But you're going to look at 2, 3 again. This is 0. This is 0. All right, the same colors. This is how I usually do transpose. Obviously, with practice, you're not going to need to do all these color coding and all of that. This is just for explanatory purposes. Very straightforward. That's the transpose of a matrix. Let's get into the determinant. Now, this is a very important concept, the determinant. All right. The determinant is, first of all, it has a few rules. All right. And it is usually associated with something called a square matrix. So the first thing has to be a square matrix. A square matrix means that the number of rows is equal to the number of columns. This is what a square matrix is. All right. A square matrix means that the number of rows is equal to the number of columns. That's all that is. Okay, so يعني a 2 by 2, a 3 by 3. So for example, 2 by 2, 3 by sorry, this is 2 by 2, a 3 by 3, a 4 by 4. These are square matrices. All right. So this is the first rule for the only rule really for the determinant. The main rule that you guys need to know for a determinant is that it has to be a square matrix. Now, how do we find the determinant? Let's say we have any a which is equal to 1 minus 3, 5, 2. All right. So this is a matrix. It's a square matrix. It's a 2 by 2. So yes, we can find the determinant of A. The determinant of A usually you can give it as det of, the notation of it. This is how you would write it. The determinant of A as det of A in between brackets. Or you would write it as the absolute value of A. All right. This is how you would write the determinant of A in a notation. And what is it going to be equal to? it is going to be equal to, let me write it down here, the determinant of A, all right, is going to be, this is the way you would write it as a matrix. You would put two straight lines. You're not going to put them as squares anymore, or like half squares like this. And you're going to write 1, -3, 5, and 2. All right? This is how you would define the determinant. And how can you find the determinant? The determinant is simply going to be these two numbers. You're going to multiply them. Then these two numbers, you're going to multiply them. And there's going to be a minus in between. This is what a determinant is. So if we go in order, it's going to be 1 times 2. This is the first step, which is you're going to be multiplying these two. All right? That's the first step, multiplication of these two. And then, second step is, I'm just going to write this multiple times. Second step will be, is you're going to take these two and multiply them as well. So it's going to be 5 times -3. And there is going to be a minus sign in between. A minus sign in between. This is the rule for a determinant. Simple. With practice, you're going to get used to it. So you take the first and last two numbers. This is for a 2 by 2. Keep in mind, this is for a 2 by 2. A 3 by 3, it will change a little bit. But for a 2 by 2, the most important one, you're going to have to do 1 times 2 minus 5 times -3. And this is going to be your determinant. So this is going to be equal to, so this is equal to 1 times 2 is 2. All right. 1 times 2 is equal to 2. Minus 5 times -3 is -15. So it's equal to 2 plus 15 because minus and minus becomes plus. And it is equal to 17. So the determinant of A, I should say, the determinant of A is equal to -17. Keep in mind that the -17 here, this is our answer. The answer for the determinant is not a matrix. It is a constant. It is a single value. It's a scalar, one value. It is always going to be just one value. This is the determinant of A. Very simple, just a formula you need to follow. So it is going to be the first number times the last number minus the other two numbers. So the first diagonal minus the second diagonal. All right, that's it. That's all it is. With practice, you'll get better at it. In the case of a determinant for a 2 by 2. Now, let's do a few questions before I go into a 3 by 3. Is 3 by 3 going to be in the exam or not? Someone just said wasn't 3 by 3 cancelled? Oh, sorry, it's plus 17, you're right. Just plus 17. Do you guys have any idea if a 3 by 3 is cancelled or if it's in the exam? Either way, I want to go over it just in case, all right? Because it's also an important concept. It is much longer, unfortunately, but I still want to go through it because it is also important to understand. It isn't very difficult. It's just it takes a lot of time to solve. And just in case it does come in the exam, I will go over it. But the 2 by 2, it's clear, right? It's very easy. I'm going to do one more example just so you guys get the idea. Let me find a given matrix anywhere here. All right. I want you guys to tell me, what is the determinant of this? B is equal to 3, 2, 1, 5, 2, 0. What is the determinant of this, guys? Can you guys tell me what's the determinant of B? لازم سريعين تجاوبوني. The determinant. I don't want to know the size of it. I want to know the determinant. It is not possible. Why? The one and only rule is it has to be a square, not square matrix. بما معناه rows are not equal to the column. ايه بس انت قلت كنا ما في، يعني مو متأكد يعني، فانا ابغاك تتأكد. See that when you see something that is not a square matrix, instantly know that the rows are, if they're not equal to the columns يعني خلاص ما في. ايوه جيابك ما في. زين directly. So we cannot find the determinant or it doesn't exist at all. زين اكيد ما في تعيبني. So let's do one more example. Let's say a matrix C. ما في ال 3 by 3 قصدكم ما في ال 3 by 3 matrix. I'm still gonna go over it just in case. لأن I'm gonna just so you have something to refer to احتياط. زين. It's actually good practice to do for determinants for 2 by 2 when you're doing a 3 by 3 matrix, which we'll look at soon. But let's say we'll do one more 2 by 2 first. 1 minus 4, 2, and 9. All right. Let's say we have this. 1, 2, minus 4, and 9. Again, first step is the determinant of C. So absolute of C is going to be equal to 1, 2, minus 4, 9. We're going to multiply these two values. 1 times 9. Put a minus sign. And then we're going to multiply these two values. Minus 4 times 2. Simple, very easy. And that's it. So it's equal to 9 minus 4 times 2 is minus 8. Minus and minus becomes plus. 9 plus 8, which is equal to 17. على حظنا 2 random matrices وطلعنا الجواب 17. يلا تعال خذ. All right, this is how you would find any determinant of any matrix. It is a very important concept, but very easy, very straightforward. ولكن if you do not remember the formula, you might get confused. So you just multiply. Again, you multiply these two, and they will have a minus in between. That's it. All right. So you'll multiply 1 and 9, and then you're going to put a minus, and then you're going to multiply the 4 and 2. Remember the order. It's going to be the first and the last first. So 1 times 9 first, بعدين minus 4 and 2. All right. Let's see a 3 by 3 matrix. You know what? I don't even see a 3 by 3 matrix in the worksheets يعني. So I don't think it is going to come. I want to just double check. لأن in the slides it is there, but I will skip it for now. We'll get back to it. I will go explain the other concepts that will be coming. زين. Just in case يعني. And then if we have time by the end, I'm just going to do a very quick 3 by 3 one time, so you guys just have a general idea of it. All right. There's two more things you guys need to know about matrices. There's something called the adjoint of a matrix. The adjoint is very simple. All right. So if let's say we have A is equal to 1, 3, minus 2, 4. Okay. I don't like this. I'm using the same numbers a lot. Well, 0 and 5. 1, 0, minus 2, and 5. Okay. The adjoint of this matrix is going to be represented with ADJ of A. Okay. This is how you write the adjoint of A. Just ADJ of A is going to be equal to, it's also a matrix. What you're going to do is you're going to flip these two. The 1 and the 5 are going to be flipped, so it's going to become 5 and 1. زين. And sorry فيني عطسة ما قاعدة تطلع. Just a second. ما قاعدة تطلع. إنزين. And you're gonna take the negative values. You're gonna multiply these two by minus, or you're gonna take the negative value of each. إنزين. And you're gonna swap the sign. So this is going to be minus 2. And this is going to be minus 0 minus 0 is just 0. So if I simplify this, the adjoint of A is equal to 5, 0, then minus 2 becomes 2, and 1. All we did again, let's take another example. A is equal to 3, minus 5, 2, and 1. Okay? Again, what you're going to do is you're going to swap the positions of these for the adjoint. So adjoint of A, let's call this B actually, عشان ما يكون فيها خربطة. B. The adjoint of B is going to be equal to 1 and 3 are swapped in position. And these you are going to multiply with a minus sign for both. Best. So it's going to become minus 2 minus 5 becomes plus 5. And this is the adjoint of a matrix. The adjoint, very rarely it is used alone. This is usually used with the next concept, which is the inverse of a matrix. Okay? The inverse, which is a very important concept as well in general. Again, the inverse of a matrix only exists for a square matrix. The adjoint as well, by the way. The adjoint only exists for a square matrix. All right? So make sure that we are dealing with a square matrix, and you will see why in a bit. Now, the inverse has also one more rule for it, all right, which we will look at in a bit. But before that, what is the general rule of an inverse? So let's say we have A is equal to 1, 2, minus 1, 4. Okay? This is our A. A inverse, it will be written in this way. A to the power of minus 1. This is A inverse. This is how you would write A inverse. And it's going to be equal to 1 over the determinant of A times the adjoint of A. Right? You can just put it this way. Times the adjoint of A. Okay? Very simple, very straightforward. The determinant of A times the 1 over the determinant of A times the adjoint of A. This is the formula for the inverse. So the first step we need to do is find determinant of A, which is just determinant of A. All right? So it's going to be equal to the determinant of A is 1 minus 1, 2, and 4. 1 times 4, 1 times 4, minus 1 times 2. So it's going to be equal to 4 minus 1 times 2 is minus 2. So it's 4 plus 2. So it's equal to 6. So we found the determinant of A is equal to 6. This is our first step. Second step, find adjoint of A. Oops, this is determinant. Find the adjoint of A. So adjoint of A is equal to, again, all you're going to do is you're going to swap the 4 and the 1. So 4 and 1 are swapped. And then you're going to multiply by minus here and here. So minus 1 becomes plus 1. 2 becomes minus 2. All right? So now we found the adjoint of A. And now the third and final step is find the inverse of A, which is just A inverse, A to the power minus 1. So we can now just simply apply this equation. So A inverse is going to be equal to 1 over the determinant of A. What is the determinant of A? It's 6 times the adjoint of A. What is the adjoint of A? It's 4 minus 2, 1, and 1. Remember, this is just multiplication, scalar multiplication, so we can distribute this inside. So this is going to be equal to 1 over 6 times 4, 1 over 6 times minus 2, 1 over 6 times 1, and 1 over 6 times 1. Okay? A inverse is going to be finally 4 over 6, which is 4 over 6, minus 2 over 6, 1 over 6, 1 over 6. Obviously, you can simplify this a bit more. The fractions, you could say 2 over 3, minus 1 over 3, 1 over 6, and 1 over 6. All right, doesn't matter much, but this is how you would solve for the inverse. 3 steps. First step is find the very first step, let's call it step 0. Check if it is a square matrix. If it's not a square matrix, you cannot solve for it. Step 0, is it a square matrix? If it is, then you can find determinant, you can find adjoint, you can find inverse. So step 1 is finding determinant to find the inverse, then find the adjoint. Then you multiply, you do 1 over 6 or 1 over the determinant by the adjoint, and that's it. So there is one small thing. The second step, okay, let's call it step 0.1. Make sure determinant is not equal to 0. ليش؟ لأن we have 1 divided by determinant. If 1 is divided by 0, you cannot find the inverse. All right? So if determinant is equal to 0, determinant, if it's not equal to 0, you can find the inverse. All right? So these are your two rules. If the determinant is equal to 0, the inverse does not exist. You cannot find the inverse. These are your two rules. It has to be a square matrix, and the determinant has to not be equal to 0. And then you just apply. They're steps, very simple steps, and you follow them. Is this clear so far? Any questions about what I have covered? Then after this, خلاص, we're going to go right into multiplication of matrices, and that's its whole own story. يعني. Any questions? Nothing? Clear? All right. Just give me a few minutes. Let me catch my breath. زين. صوتي شوي قاعد يروح لنا. أعطوني 5 دقائق. Okay, we will be back at 11. 11 شنو؟ 1:12. Okay, 1:12 p.m. I'll be back. And then we will start with multiplication, and we'll be done with matrices اليوم إن شاء الله. Back at 1:12. All right. Okay. And then there are different ways in the calculator to find determinant up to a 3x3, I believe. At the عندكم نفس calculator that I have, which is the FX991ES Plus, which most students have. I will explain that in a bit as well when we come back, يعني in a minute. في أحد عنده ريكورد المراجعة من اليوم الأحد. I will send it right now to you in chat. What I sent in chat is the recordings for everything, all right? For everything related to foundation and all the future ones that will also be added to it. Now, to use a calculator, زين, to use a calculator very quickly, I'm just going to go over it. The mode for matrices is mode 6. زين. As soon as you hit mode 6, بيطلع لكم matrix with a question mark, and then it will say give you three options: matrix A, matrix B, matrix C. So let's say matrix A, we click on it, we'll hit the number 1. Once you hit the number 1, you're going to get matrix A m times n at the very top. What does this mean? Row by column. Which row, which column? The order of the matrix. So for example, if we're looking for determinants and all of that, we're looking at 2x2s. So we're going to hit the number 5 for a 2x2 matrix. Okay? Now, let's put in a simple matrix. 1 equals 2 equals 3 equals 4 equals. All right? So it's a 1, 2, 3, 4. And then you hit equal again. You're going to see that, or you're going to hit AC now. خلاص. Now you have saved, after that, hitting the last equal, you would have saved your matrix. To check or even use the matrix, you're going to hit shift number 4. You're going to see it says matrix on top of it. You're going to see a lot of things that are coming. All right. You're going to see dim, data, matrix A, matrix B, matrix C, math answer, determinant, and TRN. All right. So to check for the determinant, all you have to do is hit 7. And then you're going to notice DET comes out. All right. لا ما قاعد اكتب شيء. I'm just talking about the calculator. فاذا انتم عندكم الكالكوليتر you could just follow along. DET is coming out. DET بعدين you will hit again shift matrix وبتضربون الماتريكس that you have already hit, which is number 3 for matrix A. Close, enter. And that's how you can check for your determinant. طبعا this is the only mode I know of. There is definitely more ways you can utilize this. Obviously, you'll be able to add and subtract matrices also using this. You can go and set, for example, a second matrix, matrix B of the same size, using the same thing. Then, that's it. Mode 6. Okay, mode 6. This is for matrices. Okay, get your calculators out كلكم الحين معاي. Mode 6 for matrix. بيطلع لكم 1 2 and 3 اللي هم مات A مات B مات C. فانتوا click on 1 for mat A. Okay, so when you hit on 1 بيطلع لكم الحين options. You're going to get 6 options. Most of the time you're going to be hitting option 5. This is just the size of your matrix. Option 5 is going to be a 2x2. Here you're choosing just the order of the matrix or size. Okay, and when you hit 5 بيطلع لكم الماتريكس نفسها. So you're going to fill out your matrix. So you're going to see something like this: A and the matrix هني. But just put 1 2 3 4 just for testing purposes for now. And then you're going to hit, so 1 equal. So it's a 1 equal, 2 equal, 3 equal, 4 equal. Okay, so 2 equal, 3 equal, 4 equal. Once you do that, خلاص, you're done. You have set up your matrix. Now you can hit the AC button. Usually it's colored green, the AC button. Then, and you're going to go back to your main menu. If you notice at the very top of your calculator screen, then if this is your calculator, at the top of the screen هني مكتوب math. So you know that you are in matrix mode. At the very top is very small. زين وبيطلع هني number 0. All right? So now you know that you're in matrix mode. Now you're going to hit shift, all right, plus the number 4. The number 4. Okay? On top of it, if you notice, it says something like this. It says like matrix. Okay? So you're going to hit shift and 4. To find the determinant, you're going to be just simply clicking on number 7, which says DET. And then you're going to hit again shift plus 4 again. I'm going to do this one more time. Shift plus 4. And you're going to hit your number 3, which is matrix A. All right? Number 3, which is matrix A. And then you're going to close the bracket and you're going to hit equal. Then you're going to hit equal. And you will get your determinant of A. Okay? That's it. These are the steps to find the determinant. طبعا تقدرون تحوصون في now you know the basics. زين تقدرون تحوصون فيه so you can do the addition and subtraction as well. يعني you're gonna set up your matrices in the same way. You can set up a matrix B as well of the same size, and then you can add them up and just double check if your answers are correct. Okay. Now let's get into multiplication of matrices. زين زين with multiplication of matrices and something that is called Crammer's rule, which is very important later on. Very simple. Made some multiplication of matrices also, it's very simple. It just follows its own rules. Okay. Inshallah, if there's time, I will try to solve that question. Now, let's get into multiplication. So for multiplication, there's a very specific rule that you guys must follow. All right. So let's say we have two matrices are one of the size 1, 2, 3, 4. Okay. So this is A. Actually, let's make it a 2 by 1. So this is A, 2 by 1. Okay. This is a 2 by 1. 2 rows, 1 column. Let's say we have another matrix that is 1, 1, 2, 3. Okay. This is a 2. Sorry, this is a 1 by 3. All right. For the case of multiplication, the rule is which types of matrices can you multiply? So we have here our row times column. Then, and we have here our row times column. So when these two are the same, when this C is equal to the red R, then you then on and only then you can multiply the matrix. then بما معناه, we're going to look at these two values. Okay, actually let me use just highlighter, it's better. We're going to look at these two values. Nope, that was not better at all. These two values. All right, 1 and 1, the column of the first matrix and the row of the second matrix. When this C is equal to this R, then and only then we can find the then we can multiply these two matrices into each other. And one more extra thing is, if we look at these two, this R and this C, then these two are going to be, this R and this C, R times C is going to be your solution. And then R times C, this is going to be your solution, the size of your solution. So it's going to be, in this case, it's going to be 2 by 3 as a solution. Tamam? So we know we're going to have 2 rows, 1, 2, and then we're going to have 3 columns. All right? So again, let me do a quick recap. The rule is to be able to multiply two matrices is the number of columns of the first one, the C over here, has to be equal to the number of rows of the second one. C has to be equal to R. This is very important. All right? This is super important. Then and only then we can multiply a matrix. And the solution is going to be the remaining row times the remaining column. That is going to be the size of the solution. All right. This is just talking about sizes and whether or not we can multiply. We're not even doing the multiplication yet. This is only to justify if we can do the multiplication or not. Then, so the way to do multiplication is you are going to find, let's take this example again, let's take it down. The method of multiplication is going to be, so since this first step was only to check whether or not we can do the multiplication. And yes, we can, because this is correct. C is equal to R. When C is equal to R, we can multiply the matrix. In this case, C is equal to R. They're both 1, so we can multiply. All right? Now, how are you going to do the multiplication? 1 second. Two, 1. Yeah, okay. I wish I did a 2 by 2 example because now this might get a bit confusing. Bess, how are you going to do the multiplication? Because this is a very simple case where it's only a 1 and by 1, we are going to go step by step. So we know our solution is going to be equal to a 2 by 3. Then, so the first thing we are going to do is we are going to multiply 1 by 1. All right? This is the first thing. So this was the first row. All right? And this is the first column. So this is going to go into location 1, 1. All right? Let me color code this. So the first row and the first column. Remember, the answer is going to be first row, row times columns, right? So it's going to be the first row, first column. This is going to be the location of it. So it's going to be 1 times 1. Okay? This is the first one you're going to multiply. The next one is going to be this one again, multiplied by 2. Okay? And this location is, the row is the same, it's the first row, and the column is the second column. So it's going to be over here, 1 by 2. And you're going to do the multiplication. Again, let me write these on the side. Actually, it will be better. So this is 1, 2, 1, 2, 3. So it's 1 by 1, 1 times 1. The second one is going to be 1 times 2, 1 times 2. The third one is going to be again 1 times the third number 3. So it's going to be in the last location, which is 1 times 3. Okay? Now we are going to do the exact same thing again with the bottom one. All right. We're going to multiply the 3 by the 1 again. So it's going to be 3 times 1. And then we're going to multiply the 2 by the 3. So it's going to be 3 times 2. And then we're going to multiply خلصوا كل الهايلايترز. And then we're going to multiply the 3 by the 3. So it's going to be 3 times 3 over here. And this is how you do your multiplication of a matrix. In this case, because we only have 1, the columns and the rows is equal to 1, it is very direct and very straightforward. You just have to multiply this into each one, كأنكم as if you're distributing. It's almost as if you're distributing, okay? Now, let's do another example, and then you simplify these. 1 times 1, 1 times 2, and then this is going to be equal to 1. 1 times 2 is just 2, 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And this is your final answer. This is the final answer of multiplying 1, 3 by 1, 2, and 3. And then let's do this for a bit more complicated situation. Just a little bit more. So I can show you how it will be done in that case. Let's say we have a matrix A is equal to 1, 4, minus 2, and 3. So this is a 2 by 2. And B is equal to 1, or let's say minus 1, 3, 2, minus 2, 4, and 1. Okay. So first things first, we check the rows and columns. This is a 2 by 3. Sorry, a 2 by 2. And this is a 3 by 2. So can we multiply these two or no? Tell me this. Can we multiply these two or no? 3 by 2. Nope. لأن our 2 and 3 in the middle over here, they are not equal. Exactly. That is the whole point. So we cannot multiply A and B. However, when can we multiply them? If this was something like this instead. If this was 1 and 2. All right. So if it's this case, this is where we can multiply them. This is where we can multiply them. All right. Here, we are going to have 2 rows and 3 columns. Okay, we're going to have 2 rows and 3 columns. Now, we know that the columns of the first one are equal to the rows of the second one. So in this case, now we know that these are we can multiply them since these two are equal. These two are equal, so we can multiply. But the solution is going to be A 2 by 3. All right. This is going to be our solution, a 2 by 3. It is going to look something like this. So we have 2 rows, 1, 2, and then 3. If you notice something, this one was also a 2 by 3. And then, even though it was a 2 by 1 multiplied by 1 by 3. So it doesn't matter how big the middle part is, the solution will always be the same on the outside. However, the solving here is going to be slightly different. And let's see how it's going to be. And then, so we have A and B. Let's multiply A and B and find out how much the solution is going to be. And then, so we know it's a 2 by 3. So we know that the solution is going to have 1, 2, and then 1, 2, 3. Tamam? First things first, we are going to look at the very first row. And then now we're dealing with two columns. We're not dealing with one column. So we're going to look at the first full row, and we're going to look at the first full column. And then we're going to multiply the 1 by the -1, and then we're going to add up the -2 and 3. So the blue part is going to be, this blue part is going to be 1 times -1 plus -2 times 3. All right? All of this, the solution of it is going to be in 1, 1. In 1, 1. And then this is how you will actually do the multiplication. فبيكون -1 plus -2 times 3 is -6. So the final answer is going to be -7. So here we're going to have -7. All right? Let's do this again for the next one. So 1 and -2, -1 and 3, this is going to be your solution for 1, 1, because we are dealing with, here we look at the rows, so this is row 1, row 2, and here we're looking at the columns, so we're looking at 1, 2, and 3. So 1, 1 is going to be -7. Now we're going to look at 1, 2. All right, we're going to look at now at 1, 2. So we first looked at 1, 1. Now let us look at 1, 2. Then this is what we're going to be multiplying now. The first number, which is 1, خلصنا من البلو. The first number, which is 1, and the first number here, which is -2. So it's going to be 1 times -2 plus -2 times 4, which is equal to 1 times -2 is -2 plus -2 times 4 is -8 equal -2 minus 8 is -10. So our 1, 2 is -10. Again, we're going to do the same thing. We're going to look at the same row, next column. So we're going to do the same thing. We're going to look at this, and we're going to look at these two. So we are multiplying the 1 here with this 1, and then we're multiplying the -2 here with this 2. This is what we are doing. This is the order we are doing. Multiplying the first number with the first number, then we're adding the next two numbers that are being multiplied. For 1, oops, وين رحت أنا الحين؟ زين. For 1, 3, we are doing 1 times 1 times 1 plus -2 times 2. This is going to be equal to 1 plus -4, which is equal to -3. This is going to be our third number. Now we are going to repeat the exact same thing for the second row. So now for the second row, we're going to look at 4 and 3, and we're going to look at -1 and 3. Again, same exact thing. So let me just make this a little bit smaller. Keep it on the left here. Then. So this is, we finished from this part. Now we're going to do the exact same thing for the second row. 1. Now we finished from row 1. We are in row 2. So we know that these are all going to be row 2. We're going to do row 2, 1, then row 2, 2, then row 2, 3. All right. So row 2, 1, row 2, and column 1, it's going to be 4 times -1 plus 3 times 3. All right. So it's equal to 4 times -1 is -4. 3 times 3 is 9. So it's equal to 5. This is going to be the number here. Same exact thing again. We are going to look at 4 and 3, -2 and 4. Then 4 times -2 plus 3 times 4. If you go in order, تروحون بالترتيب slowly, it's not going to be complicated. Yes, it looks like a lot of calculation, but they're very easy, simple calculations. 4 times 2 is -8, plus 3 times 4, which is 12. So this is going to be equal to 4. Second number is 4. And the last and final number we're going to be looking at is 4312. 4 times 1 plus 3 times 2 is equal to 4 plus 6, which is equal to 10. And this is your final answer. Very simple, very straightforward. You just first step again to repeat. You make sure that the number of columns of the first one is equal to the number of rows of the second one. Then you make sure that you're going to look at the other two numbers to find out the size of your matrix. So it's going to be a 2 by 3 matrix. That is going to be your solution, which is what we found here. Then we set up our matrix. We write the number of rows 1 and 2 and the number of columns 1, 2, 3. We know that we have 2 rows from the first one. This is where we're getting our rows, and the columns from the second one. So we're going to multiply each row by each column. That is the whole idea. And we're going to go step by step until we solve all of it at the bottom. All right. So I'm just going to highlight a few of them here so you guys understand. So we did this with this, and we were doing this, for example, with this. All right. This is how we were multiplying. We were multiplying each one in order. Tamam? Any questions about this before I go to Cramer's rule? It takes some time, yes. I know I've noticed a lot of you were asking about the calculator. I'm pretty sure you can do it by the calculator. I haven't tried myself, to be honest, but I'm pretty sure you can do it in the calculator. And I will test it out. But before that, I need to go to the last concept, which is Cramer's rule. This is one of the most important rules that you guys need to know to be able to solve almost any simultaneous equation. So you remember from before, we had simultaneous equations. All right, let's take an example. 5x plus y is equal to 13, and 2 minus y is equal to 4x plus 3, for example. Then we have these two equations. Simultaneous. So we need to solve for x and solve for y. We remember before we used the substitution method and the elimination method. There is another method using linear algebra, which is using matrices, that we can solve. Now, first things first, we need to order these very properly. The x's above under each other, y's under each other, and the constants on the right side, like we always used to do for simultaneous equations. So the first equation is fine, but the second one, we need to fix it up. So we need to take the x to the other side, and we need to take the 2 over here. So this x we want to take over here, and this 2 we need to take over there. And that's what we're going to do right now. So it's going to be minus 4x minus y is equal to 3 minus 2. So in other words, minus 4x is equal to minus 4x minus y is equal to 1. So now if we rewrite our simultaneous equations, we have 5x plus y equal 13. So 5x plus y is equal to 13. And minus 4x minus y is equal to 2. All right. Sorry, it's equal to 1. It's equal to 1. So we have our equation 1 and we have our equation 2. Tamam? So now that they are in this specific order, this is how you would properly write them in matrix form. Obviously, yes, I know all of you are going to say we're just going to use mod 5.1 to solve this in the calculator, which you can, but this is the whole concept of how to solve it as a matrix. We are going to look at the x values, right? We're going to look at the x values, and we're going to put them here in order. So it's going to be 5 minus 4. the x, the constants of x, only the values, the numbers, okay? Minus 5 and 4. Let me make this a little bit bigger. So these are our x values, minus 5 and 4. And then we're going to look at our y values. In this case, when there is no number, that means it's 1. Minus 1 and plus 1. So we have 1 and negative 1. These are our y values, okay? There's something here which I will explain in a bit. You don't need to know really well, but it's just the proper way of writing it. And then we're going to write your solution. It's equal to the solution. What is our solution? It is just the remaining parts here, 13 and 1. Okay, so 13 and 1. Tamam? This is how you'll write it in vector, in matrix form. ولكن, what is in this box? You don't need to know this, but I'm going to explain it anyways. This is just x and y in the order that you have written them on the left side. Then, how so? Because remember when we were doing matrix multiplication, and then this matrix multiplication, if we do the matrix multiplication here, we are going to get these two simultaneous equations as the answers. Okay, that is why. Then if you notice, we're going to do 5 times x, 1 times y, and then minus 4 times x, minus 1 times y. And then it's going to be equal to the solution. All right, this is why, this is how we usually would write them. Now, okay, so here, this is our solution. Okay, this is our solution. The first thing we're going to do is we're going to look at our basic matrix and we're going to find the determinant. We'll call it capital D is equal to the determinant of this matrix, which is 5 minus 4, 1 minus 1, which is equal to, now at this point you guys should know how to find the determinant. It's just 5 times minus 1 minus 4 times 1. So it's equal to 5 times minus 1 is minus 5 minus 4 times 1 is minus 4. So it's equal to minus 5 plus 4. So it's equal to minus 1. Perfect. So the first step is determinant should not be equal to 0 to be able to solve this. And the determinant is not equal to 0. It's equal to minus 1, negative 1. So we can solve it. Perfect. That is the first thing. Now we are going to find something called dx, all right, and dy. But let's start with dx. If I just copy paste this here, let's make it a bit smaller. Then, now to find our dx, our dx is going to be the determinant of the same matrix again. However, our x value is going to be replaced by the solution, which is 13 and 1. So the x value is going to be replaced by the solution, which is here. This is the solution. And the y value is going to stay the same, 1 and minus 1. Okay? And you'll find the determinant again. So 13 times minus 1. Oops. 13 times minus 1 minus 1 times 1. Okay? So it is going to be equal to 13. Let me, 13 minus 2. No, sorry, minus 1. بدل مخي يضرب شوي. 13 minus 1. Negative 13 minus 1. I'm sorry. This is minus. So 13 times minus 1 is minus 13. Minus 1 times 1 is just 1. So this is going to be equal to minus 14. Okay? So our dx value is equal to minus 14. Tamam? Now we're going to find our dy. Same exact concept. I'm just copy pasting this down here one more time so we can look at it. So same exact concept. dy is going to be equal to, we're going to have a matrix here the determinant of a matrix, the x is going to be the same, but we are going to replace the y with the solution. So this is going to be 13 and 1. So this is now we're going to find the determinant of, which is 5 times 1 minus 4 times 13. So it's going to be equal to 5 times 1 is 5 minus 4 times 13 is 52. All right. So minus 52 is basically 5 plus 52. So it's equal to 57. Yeah, 57. So dy now is equal to 57. Tamam? This is what we have done so far. Again, to repeat, nothing complicated. We simplified our simultaneous equations so that they're all in order. The x's are above the x's, the y's are above the y's, and the solutions are on the right-hand side of the equal sign. Then we wrote it in matrix form. We just write the constants, the 5 and the minus 4 of x. Then the order in order of y, so 1 and minus 1 of y. Then the solution, which is 13 and 1 on the right-hand side. After all of this is completed, we are going to find the determinant of the original matrix, which is the 5, minus 4, 1, and minus 1. We will call it D. We found the determinant to be minus 1. So D is equal to minus 1. Okay? This is the first thing we find. Then we are going to find dx, where we are going to replace the values mal x and zain by the solution, and then find the determinant again. And then we did find the determinant to be minus 14. Okay? And then again, we will repeat the same steps for dy, where we're going to replace the y values with the solution, and then we're going to find our dy. Okay? Now, let us get all of our d and dx's and dy's next to each other. So this is d equal 1, minus 1. This is d equal to dx, which is equal to minus 14. And we have our dy over here, which is, so we have our d equal minus 1, dx equal minus 14, and our dy, which is equal to 57. What do we do with this? It's very simple. Now x is going to be equal to dx over d, and y is going to be equal to dy over d. And that's it. And that's how you find your solution for x and y. So x is going to be equal to minus 14 over minus 1, and y is going to be equal to 57 over minus 1. Tamam? So if we simplify, x is equal to minus 14 over minus 1 is just 14, and y is equal to minus 57. All right? And we are done. This is the whole idea of using Cramer's rule. Tamam? You can always check, obviously, by putting the numbers back into here. So 5 times x is equal to 14. And then let's just check it real quickly. So these are the answers we got. X is equal to 14. Just in the calculator very quickly, we're going to do 5 times 14 plus negative 57. It's equal to 13. So x is correct and y is correct. It satisfies the first equation. Let's check it with the second equation. Minus 4 times 14 minus 57 is equal to 1. So we have the correct answers. All right. This is how you would solve the simultaneous equation using matrix form. It is the fastest way. It is a bit more complicated sometimes if you do not understand the basic rules, but trust me, this is the fastest way to solve any simultaneous equation rather than doing substitution and elimination. It's very basic steps. You find 3 determinants, which take 2 seconds to find each, and then dx over, dy over, and that's it. You're done. You find your solution. All right, and this is what they call Crammer or Cramer's rule. And we are done with matrices. This is all of it. Any questions so far? Can I go up? Oh, قبل 10 دقايق you're asking to go up. How up do you want me to go? I don't know where you were talking about. Can you go up? هني? You want to see this? Anyone else has any other questions? Most of you were asking about the calculator. Yes, I will factorize that one. I do want to do one more factorizing. But someone else was also asking another question about, before I move on, the last question, this one. Which part do you want to see exactly here? This part? Okay. Before I start solving other questions, does anyone have any questions about matrices as a whole? Let me test out in the calculator very quickly the multiplication. Yes, you can simply do the multiplication through the calculator, very straightforward as well. You need to see the question. This was the question. 5x plus y is equal to 13. 2 minus y is equal to 4x plus 3. Questions 11, 12, and 13. Actually, I'm going to solve question 13 as well from that. That's very important in matrix. And then on the calculator, yes, you can do matrix multiplication. Just again, mode 6. You will set your matrix using mode 6. So you go to matrix A and then you will write the numbers of the matrix. And then you will go to matrix B and you will write the number of your matrix. And then when you've done, you're going to go with shift 4, which is where you find the shift 4, which is where matrix is. You will hit 3 for matrix A. You will hit the multiplication sign, so times. And then you will hit shift 4 again and you will go for the other matrix. You're just going to hit equal and your answer will be in matrix form. So you can do multiplication to check, you could say, on the calculator. آخر مسألة اسمها Cramer's rule. This is called Cramer's rule. زين? It is how to solve simultaneous equations. I want to solve just one quick question from here, and I want to try to solve the factorization question you sent and the algebraic fraction questions that you have sent. So the last thing I want to explain here is there's a question that says, find two values of x such that, let me actually just take a screenshot of this. This is a very good question they can ask in the exam. Find the two values of x such that this matrix is equal to 1. So we have this matrix, x, 2x, 2x, and x plus 4. Then, so what they mean by this is the determinant of this should be equal to 1. Okay? This is what they mean. They mean that the determinant of it is equal to 1. So how are you going to do that? You're going to have to do x. Again, you're going to do this times this first. And then you're going to do this minus this times this. All right? Doesn't matter which one times which, but in that order. So it's going to be x times x plus 4 minus 2x times 2x equals 1. Why is it equal to 1? Because it's equal to the determinant. This is the determinant. And now we simplify and solve the equation. That's it. So x, we distribute x squared plus 4x minus 2x times 2x is minus 4x squared is equal to 1. Take everything on one side, we have a quadratic equation. X squared minus 4x squared is minus 3x squared plus 4x. Take the 1 to the other side, it will become minus 1 equals 0. And that's it. And then you will find mod 5(3) is equal to minus 3 plus 4 minus 6. You'll find your two answers and you are done with this question. All right? You should already know how to solve a quadratic using a calculator or even without a calculator. Let me solve another question now outside of matrices. Everything else that I've seen from matrices are very straightforward, or I have already explained the concept. 3x3 matrices, I'm not gonna go through because apparently you guys, based on what you guys told me, it's not coming on the exam. So if it is coming on the exam, blame your colleagues, not me. Question 11. It's a 3x3 matrix. It's a 3x3 matrix. I'm not gonna go through that. It's the determinant for a 3x3 matrix. So I'm not gonna go through a 3x3 matrix. Aslan, I don't have time anymore to explain a 3x3 matrix, unfortunately. Someone asked me a question about simplification for algebraic fractions, which I will go through right now very quickly. All right. Simplify 84 z to the power 14 over 3y squared times 21y 25 over 17z. Very straightforward, very easy, okay? You're going to multiply everything first. So 84 times 21, the numbers are going to be multiplied together, and then z 14, y 25, divided by, we're going to multiply again the numbers first, 3 times 17, and then y squared z, okay? Simplify the numbers. 84 times 21 is equal to 1,764. And below is 3 times 17, which is 51. And we're going to reorder these so that the y's are above each other and the z's are above each other. Y squared and z. Another way we can write this is to simplify it on us, 164 over 51 times, we're going to keep the y's by themselves, 25 over y squared, times z 14 over z. And now we're going to look at the powers. This minus, because it's division, this, and the same thing for z, this minus, because it's division, this, which is 1. Okay? So the answer is going to be 1764 over 51 times y25 minus 22, y25 minus 2, sorry, not 22, times z 14 minus 1. Okay? So that's it. We found our solution. So 1764 over 51 times y to the power of 25 minus 2 is 23 times z to the power of 14 minus 1 is just z to the power of 13. Therefore, 1764 divided by 51, can it be simplified more? It can be. Just put it in the calculator. It will give you 588 over 17 times y23 times z13. That's how you solve this question. And then I'm going to do one more factoring question, and I will, let me see. Um, 35z power 13 y power 23. ما أعرف من وين يابا 35. But if you notice, like the power is what you need to be focused on most of the time. Then there is only one which has z that is 13 and y that is 23 in the solution that I can see. لا في اثنين، في 108 وفي 35. 35 من وين يابا؟ They're rounding. Okay, so they're just doing 588 divided by 17. Put it in the calculator. This is what they're doing. Divide 588 by 17. So it's going to be 34.588 in the calculator, y23, z13. This rounded to the whole number, so you're going to be rounding up to the whole number over here. Is this greater than or equal to 5? Yes, it is, so you're going to add 1. So this is going to be 35 y23 z13. This came from just dividing this by this in the calculator and hitting SD, okay? Now let me do, because time is running out, let me do, the options are correct, by the way. So let me do one last question, which was someone asked me what the factorization is. The question is 5x squared minus 7x plus 94 over 7x squared plus 19x minus 40. Again, we'll look at the top one first, and then we're going to look at the bottom one. So the top one, we're going to solve for it. The top one is, we have 5 times 94. So first step is finding AC, which is 5 times 94 is equal to 470. And then, wow, that's a big number. Then, is there another way to simplify? Nope, that's unfortunately the only way we can do it. And then there's 2. Step 2, look at our B value, which is minus 7. We're going to have to look for two numbers that when you add or subtract, when you multiply, you get 470. And when you add or subtract, you get minus 7. Okay? And I can tell you from now, the numbers are both going to be negative. Why? To get 470, then, to get 470, you have to multiply either two positive numbers, or you're going to have to multiply two negative numbers to get a positive value. Then, here, if we add two pluses together, we're never going to get a negative number. So it has to be two negative numbers. So we already know the first step is there going to be two negative numbers. That's the first step. Second step is finding all the factors you can for 47. So we have 47 and 10. That's for 70. That is a lot of numbers. Let me just check a few numbers and divide by 4. Yani this is how I usually do it. I go onto my calculator and I start just dividing number by number with the big number. Yani this 47. I start dividing it by all the numbers that I could divide it by. طريقة GCF عندنا 47 and 10. These, when you're dividing 470 by 10, you're going to get 47 and 10. I think 47 is a prime number as well. It has nothing else. And this 10 is going to be 5 and 2. Okay, since I'm very short on time, I'm going to solve this by myself because I need to think about it a little bit to see if there's another way to solve this, to factorize this. And inshallah, at the beginning of next session, try to come early because in the first 10 minutes, I will explain this question. Tamam? Thank you guys very much for attending. I hope this session was useful.